Hello, this is Mrs. Decker, and this is notes on Objective 5, Energy in Waves. Objective 5 only has one I can statement in it, and it is I can explain how the wavelengths of light emitted by an atom identify the atom and the energy levels of the electrons in that atom. That may seem a bit complicated right now, but essentially what it's saying is that when you excite an element, the atoms in that element give off a certain wavelength of light, and we see that as a specific color, and we can use that specific color to help identify which atom it is. So the big questions to think about for this objective is, what is light? How is light emitted? What do electrons have to do with light? What are emission spectra? And how do flame tests help identify metals? First, we need to talk about the electromagnetic spectrum. All light is part of the electromagnetic spectrum, and if you have already taken a physics class, this term should be somewhat familiar to you. Most of the electromagnetic spectrum is invisible, like gamma rays, X-rays, UV rays, IR, microwaves, and radio waves. What the rays are, essentially, are bursts of energy. So things like gamma rays and X-rays are very harmful to you if they come in contact with your body. However, things like microwaves and radio waves are mostly harmless. The part of the electromagnetic spectrum that we can see is visible light, and visible light wavelengths are anywhere from 400 to 700 nanometers. Here's a graphic of the electromagnetic spectrum. So as you can see down here, gamma rays have the highest frequencies and the shortest wavelengths, while radio waves have long wavelengths and smaller frequencies. And the part of visible light that we can see is very, very small here in the middle. So most of the electromagnetic spectrum is not visible to the human eye. There's only a very short portion of it that we can see. So light, whether it is visible or invisible light, is a carrier of energy, and energy is proportional to frequency. Frequency is inversely proportional to wavelength. So the longer the wavelength, the lower the frequency, the lower the energy. While the shorter the wavelength, the higher the frequency and the greater the energy. So in order to relate this to electrons, we have to learn some new vocabulary. The ground state is the lowest energy position an electron can occupy. And the excited state is a temporary high energy position. A quantum is the amount of energy needed to move an electron from the ground state to the excited state. So when we're talking about ground state versus excited state, we're talking about the energy orbital that the electron is going to occupy. Remember, in Objective 4, we learned that electrons will occupy the lowest energy level before electrons start filling the higher energy levels. However, absorbing a quantum of energy can temporarily move the electron from the lowest energy level up to a higher energy level. So this diagram shows you what's happening. Here's our quantum of energy that's coming in, and the electron is absorbing it, which causes the electron to jump from its lowest energy orbital up to an excited state. Now remember, we said that that excited state was temporary, so that electron is only going to stay up there momentarily, and then it will fall back down to its ground state where it wants to be, in the lowest energy level. When it does that, it releases an energy that has a specific wavelength. We see that specific wavelength as the color. This is something that you will need to be able to explain on your quiz or your test. So using a diagram might help you. Here we see the quantum of energy coming in and the electron absorbing it. That will cause the electron to jump up to the excited state. It is a temporary excited state, so it will eventually fall back down to its ground state. When it does, that energy is released, and we see the wavelength as color. This particular wavelength is yellow. Most atoms have multiple electrons and multiple energy levels that those electrons can occupy. Because of this, more than one electron can absorb energy and jump up to the excited state at the same time. And as those electrons release the energy and fall back down to the ground state, we can have multiple wavelengths of energy released. Because of this, we get an emission spectrum, which are all of the different wavelengths of light given off by an element when it is excited. We excite elements by introducing heat usually. So each element will have its own unique emission spectrum. These are the emission spectra of hydrogen, helium, and carbon. You should copy these down in your notes using colored pencils. So as you can see, hydrogen has several wavelengths, 2 in the purple wavelengths, 1 in the blue, and 1 in the red. So the lines through the emission spectrum are what you want to copy down in your notes. When I get back, I will show you how we can see these for each element. So the type of question you would need to answer for Objective 5 is explain why a neon light gives off a bluish color. So using descriptions and diagrams, you would need to explain that the electrons in neon are excited, and that moves them up to the higher energy level when they absorb energy. That is a temporary state, and once they fall down back to the ground state, they release that energy, and we see that as the blue color. If you have any questions, please see me.